So let's have a look first at the wind forcing, the wind conditions over the Southern Ocean. Okay, and this is shown here in terms of the wind stress. Okay, the wind stress is a frictional force of the winds blowing along the sea surface, and the wind stress, the magnitude of the wind stress is proportional to the square of the wind speed. Okay, the direction is the same. What you see here in these maps on the left is an annual mean, then comes the summer mean, and then the winter mean. It shows you in terms of arrows the wind field. Okay? And if you use arrows, here the arrows, the longer the arrow and the thicker the arrowhead means the larger is the wind stress. Okay, and you can see that there are westerlies all along the Southern Ocean, and some regions stronger and some weaker, but you get sort of a band centered around 50 degrees south, a little bit northward of that. That's why it's called the Roaring Forties. Okay, and the wind stress becomes weaker as you move to the north and becomes weaker as you move to the south. Okay, these are called the westerlies. Yeah, and they exist year-round. There are some variations. Okay, some seasonal variations. If you look closely, and we see that better on the next slide, is that as you go close to the ice edge, you actually have polar easterlies around the ice edge of Antarctica. Not very strong, okay, but they are there. So now the big question is, how does the ocean respond to this force? The winds are there all the time. You know, there's no variation. How does the ocean respond to this? And there are several answers, because you could think in terms of the waves, surface waves. You could think in terms of the currents, you know, the Antarctic circumpolar current. But you can also think in terms of vertical circulations like Ekman suction and Ekman pumping. And we have a look at all of that. Okay? The first thing we want to do, just, you know, it's sometimes a little bit hard to look at these arrows and to get some information from that. We can also actually use the surface pressure distribution, air pressure at sea level height, to actually show the distribution of the wind stress. And I would just want to do that on the next slide. Okay, it's this slide. It shows you the July mean, the winter mean, and the summer mean. And what's shown here are pressure contours. And as you already learned for the oceans, these pressure contours are also in the atmosphere the contours of geostrophic winds. Okay, so the winds blow along these lines. Blow along these lines. And where the spacing is closer, that's where the winds are stronger. And you can also see here near the continent, you get a reversal of the winds near the continent. So contour maps are really useful to infer or to show the directions of the distribution of winds. Okay. And in the ocean, pressure contours are used to show geostrophic. Okay, so now how does the ocean respond to these persistently strong winds over the Southern Ocean?